See, so this was it. We talk about functions in Python. To define a function, you use the keyword def. Let's say this is the name of the function. Here we call it my function. And then in this case, it has one argument, which is name. Okay. And then this function returns a formatted string, inserting your name into it. And then we said our functions is just like a series of instructions that does something for you. And then you group it into the function name. Now, anytime you call the function, like these examples here, you can pass in different arguments, and each time the function is going to print hello. In this case now, the name will be Faith. Hello, Faith, how are you? When you call the function the second time with James, hello, James, how are you? Paul, hello, Paul, how are you? So with function now, you can have a series of code. Instead of repeating codes in your programming, you can just put it in a function, and each time you call the function, then it runs those codes on each call. So in this case, the first time you call it, it runs for Faith, James, and then the second time James, the third time Paul. Now, this in function, we have this keyword return. And what return does is, after the function has performed everything it's supposed to perform, you will return something. It's different from print statement. You will return it, which is like the function is asked to do something and it just brings the result. This can then be stored in another variable or injected into another process. It's not printing to the screen. Okay, that is the reason why when you see this line here, we have to wrap it in print statement so that we can print what this function returns. Okay, if you don't put it in the print statement, you find out that nothing will be printed, or you will just print. Yeah, if you run the function without the print statement, you will not see anything in your terminal. Let me clear this one. Do you get?
Yeah.
Yes.
Yes.
Yeah, so if you run it without the print statement, nothing will be printed in terminal because the function now is with the keyword return. But if I put print, then it will print without me calling the print on it. But just know that the return now, it's where the function brings back something which can then be stored in a variable, like in this case now, where we have a function that has two numbers, A and B, and then returns their sum. When I say total is equal to add num 3, or let's say add num 30 and 40, it will now be 30 plus 40 is 70. It will then store it in total 3. It won't print it on the screen. It's stored. I can then use total 3 for something else, which in this case, in line 18, we put it here to print total 1, total 2, and total 3, and separate them by 3 dashes. That's what this print statement is doing. Meanwhile, here, someone will say, why is add num having only one argument? 3, what am I adding to 3? When you look at the function, you have 2 elements. It takes A and B, but B already has what we call a default value. So B is already equal to 10, which means if you do not supply B, okay, if you do not supply B, B has a value of 10. So in this case, we did not supply B. It's just we supply 3, and automatically B is 10. So 3 plus 10, this will be 13. That's default value. So when you want one of the arguments to have a default value, if the user does not specify it, it will still run. If you don't have this default value and you attempt to run the function without providing the arguments that are required, there'll be an error. So you have to provide those arguments. Okay, so I think this is like a summary of what we did last time in functions. Does anyone have any question?
Okay, that line 12, if we just ignore that statement and just say non-sum equals A plus B, and maybe in terms of our operation, we print, will it have any effect?
So what you're saying is I should comment this?
Yes.
Just run this function this way. It will have an effect because there is the function.
If we
what?
Okay, if we want to print and we say maybe print a sum, that is if we just do this, knowing fully that we printed this non-sum.
So you're saying basically now that if we remove our return statement, we still have this function,
Yes.
right?
Yes.
We can call the function like line 14 is calling it,
yes.
right? You're not saying what will happen. Are we going to be able to print out anything or something, right?
Yes, if we now, after implementing the line 14 and in our print statement, will it not print the result?
It won't print the result. I've not actually tried this out, but I know it won't print the result. But let's see if it will even give us like an error. So I save it and then we run it. Python, and what's the name of this file? .py. So you can see I printed it. There's no error. What happens is the function does not return anything. So total, which I store the result of this, has the value none. Okay. Total 2 is none, and then total 3 is none, which means the function probably is executing this, right? But it's not returning it. It's just executing it and doing nothing with it. It sums it, but we can't see it. If you put a print statement like this, and if I run it, let's see what happens. It should be able to print something. Yes. So you can see now I just inserted a print statement instead of a return. When I run line 15, by the time it does the addition, it prints it 13, 20, and 70. But it does not store anything inside of total because it doesn't return anything. Total can't get anything. Total 2 got nothing. Total 3 got nothing. So they are still none. But once the function was running, I printed it for us to see. Does that make sense or to your question?
Yeah. Okay, that means it can only run just on the function, but when we call it, it will not be able to return anything.
Yes, it's not going to return anything for you because you've removed that and return keyword, and that's what it's doing there. It gives you back something. You know how when we want to get the length of a string, we can say something like, let's say this is a string. Then we can say L is equal to len. Okay, let's say the string is L is equal to this. We can now say len, how do I say it? Le is equal to length of L, right? When we want to like get the length of this string, you remember this function, len L, okay? It will
Yes.
return, it will count this string and return the value, store it here for us. This was happening because there's a return keyword inside of this len. Len itself is a function. It is written somewhere as this. Def len, something like this. Okay. And then they have implementation, series of lines of code, probably takes an argument. So is length, something like this. Then how did they calculate the length? It will be seen in the code. But now see, this is the beauty of functions. You're using the length function without having to see how it is written. Okay. Each time you just call it to see the length of an item, of a list, or of a string, call the length function. You just see the number, the result. Because the function does some lines of code, some computation, some logic, and then it returns its answer. So you can, once you just call it on it, like you can see the answer. Oh, this string is its length is 10, its length is 5. But how did it get 5 and 10? Don't know. Because it's been written as a function. All you have to do is call the function. So that's the beauty of function. Instead of you to start writing the code again, you can just call it. It will implement and return something to you. Finish. Does that make sense?
Yes.
Although this is more like a built-in function to in Python. It's built in, so it's just there in the built-in namespace once you open your Python. Okay. So we move forward to today's own now. At least we've gone through like this is basics what we did in function. Today now, we'll now begin to answer this question. Function now, we can say def my function. Let's say pass. Now, in the previous lesson, what we talk about is a function that can have maybe one argument A and have an argument B. Sorry, B should be in here. Okay, we have something like this. But let's just say we don't know how many arguments the function is going to receive. Let me use this actual function here. Let me call back this. Let me call back that function instead. So this now, we are trying to do add num. In this case, we have it dealing with A and B. So the user can only add two numbers. And we went ahead, we called it like total is equal to add num. And then we can say 30 and 40. So this now has two arguments passed to this function. But what if the user wanted to add 30 plus 40 plus 60 plus 70? So now you can see that it's trying to add four numbers. Our function cannot help him, except maybe you add the first two, you add the sum of the first two plus the next one plus then, so you're calling the function like 3 times. You can do that using this function. But what I'm trying to say is you can improve on the function such that it will be able to sum any amount of input, any amount of number the user passes to it. So in this case now, if we add 60 and then we add 70 here, of course, we didn't know the user is going to have 4 elements. What if the user now has 100 elements? You can handle that in function by defining what we call let's just say argument that is unlimited with the star, the way I did it now. So when I put star A, in this case now, the star tells it can take any number of arguments, not just A. So I'll have to also modify the function moving this, but let's just print A first so that you see something. So num sum, okay. Let me just comment this one out here. So we're going to call this function with 4 arguments, but in the definition of the function, I just put star A. I was saying that star A can then mean if I put 10 arguments, the function can take it. If I put 1, it can take 1. If I put 20, it can take 20. So any amount of number the user puts, it can take it. Now I'll print it so that we'll see what A looks like. It's if I'm just putting my mouse over it, you can see that A is a what? A tuple. Okay. So when you pass this star argument into the function, it accepts it as a tuple, which is what I wanted us to see if we print it. Can we see that? Yeah. It is passed in as a tuple. So which means the moment you put a star and then the argument, is going to always pass the argument into the function as a tuple. Now, if you want to sum it, I think you can just say num sum equal to sum A. Let's just put it that way, A, because you can call sum on a tuple. Let's save it. And then print total. Save it and run. So now you can see that because I can take any number of arguments, once it passes this, I received it as a tuple, and then I just sum the tuple. But instead of just writing sum A this way, I can say num sum is equal to 0. Then let me just use a for loop for num in A. Num sum plus equal to num. So basically what I'm saying, instead of just calling that function sum, I just wanted to implement it myself. So I just say initially 0, then for every number in that tuple, which is A, for every number in this, I will add it to num sum and then return the sum. Does anyone have any questions so far? Okay, in the absence of questions, so this is how you handle multiple argument. One function that we have been using that does this is the function print. So now you realize that whenever you call print, you can say print A, comma B, B, comma C, and so on and so forth. You can pass in any number of arguments if you remember. And that is because in the print function, it accepts any number of arguments like this. Okay, so now my mouse is over print. If you look at this write-up that came up that explains print, you see it's a function def print. Then the first argument you can see is star values, right? When you have that star values, it's just what we're talking about. It means any amount of values, but this will be returned inside the function as a tuple. all the values will enter into this function as a tuple. So a tuple that contains those values. Does that make sense? And this is the reason why the print statement can take any amount of arguments you pass to it. You can print only one item. I can say print 2, or I can put as many items as I want. You get, I can just be passing different items, even though it's 10, even though it's 100, print to carry them and execute for you, because it's working with that argument that has as many as possible. Then we move on again quickly. We could also have what we call the keyword argument. So we have a function def my own. Now, every of these arguments we've been dealing with, if I go back to the previous day, when we pass an argument like A, B, we call it positional argument. It's positional in the sense that positional in the sense that A will always be whatever you pass first. B will be whatever you pass second. Okay, so if I pass, when I call the function add num, the first number I put will be A, the second number will be, but if you want to have it as keyword, you can call the function in this way. For instance, I will say T is equal to add num, and I can say B is equal to 10, 12, comma, A is equal to 2. So when you call it this way, what I'm saying is let B, which is the second parameter, be 12, but I put it first. And I can then say A be 2. A is the first parameter, but even though I pass it in as the second position, this way the function will still resolve it to be A first before B, because I'm using positional, key value, kind of keyword pairs like this. So one way to pass in arguments to your function instead of just using positioner. Positioner is where the position determines the variable or the argument passed. But now you can define it, okay, let this argument be this, let the argument be that. Does that make sense?
Yeah.
Are we still here?
Yes, so we are here.
Is it clear?
Well,
Or let's bring in an example. Let's bring in an
yes.
example. Should we bring an example to clarify it better?
Yes, I think that will be, it will enter more.
Let me just call these names, def names A and B. Then I will just do it like this. Print. Instead of returning, I'll just print f string. First name is this, and second name is this. So here I'll inject A, and here I'll inject B. Okay, so what I'm just trying to say in this function in essence is when we call the function and pass two arguments, So the first one should be James. And let the second name be Peter. Okay, so let's save and run. Where is this error coming from?
Check the first name. His spelling, I think, is not complete. Maybe
Yeah,
from
yeah, although this error we're having is in line 7. Yeah.
okay. You
And
didn't
it says
comment.
type error, unsupported operands for at this type of addition, integer and string. So why is it happening that way? Okay, because can be here. Remove this. So where did I call? Okay, I'm calling add num and I'm using strings. So it's trying to perform this operation with strings and then it runs to error. So it's not add num it's supposed to be names. So you can see first name is James and second name is Peter because I put it like that. So what if I say something like B equal to and A equal to save, then running. Did you observe now that even though the first, let me clear this thing, it's too busy. So without doing this, if you do like this and you're running, you find out that the first name is James, which is the first name which you put, right? And the second name is Peter. Now, in our function, the first name is A, which we put here, and the second name is B, and we put it there. Now, I changed it and said, okay, the first name I'm putting, let me put it this way, B equal to, and then the second name I put it A equal to. And then I save it and run again. What you see now is, even though Peter is the second name I put, but because I assigned it to A, when in the function, it is put as the first name, which is Peter, right? So now we are no longer using position to determine the variable we are passing or the argument we are passing. We're actually kind of saying B is equal to, even though it's the second argument, but we are just injecting it at the first place. And then the first argument, which is A, we are putting it in the second place. So it doesn't now matter the position. Anywhere you put it, the code will